This is ANOVA table, whereby we have 5 columns with 4 rows. The columns, for example, sum of square, denoted by SS, DF stands for degree of freedom, mean square, denoted as MS, and F, where this is our test statistic. This is what we want. This is the test statistic. Whereby the row we have between groups denoted as A, within groups denoted as B, and total with T. Sum of square SS, so SSA is calculated as T1 square over N1 plus T2 square over N2 plus T3 square over N3 up to until how many groups that we have. Let's say that if K is equal to 3, then we stop until T3. If K is equal to 4, then we just need to add one more, which is T4 square over N4, minus with summation of S square divided by the total sample size. For SSB, sum square for within groups can be calculated as sum square total minus with the sum square of between groups. And sum square total SSD can be calculated as summation of S square minus summation of S and then U square divided by the total of sample size. For degree of freedom, number 1 calculated as K minus 1, where K is the number of groups. And for degree of freedom number 2 can be calculated as the total sample size minus with the groups. And for the total, you can calculate either df1 plus df2 or total sample size minus with 1. For mean square A, mean square between groups, can be calculated as SSA divided by its own degree of freedom, which is df1. And for MSB, mean square within groups, can be calculated as sum square of within group, which is SSB, divided by its own degree of freedom, which is df2. Finally, we can calculate F, whereby F is equal to mean square between groups divided by the mean square within group, MSA over MSB. Okay. Now, let's look at this example. Let's say that we want to determine the difference in the mean waiting time of customers served by 3 different counters, namely counter 1, counter 2, and counter 3. And the data here, the value here, indicates that the mean waiting time for the customers. For this one, we need to obtain several values. For example, N1, N2, N3. Before that, we need to write our number of group, which is K. So here, K is equal to 3, whereby we have counter 1, counter 2, and counter 3. So that's why K is equal to 3. Next, we need to obtain the sample size for each group, N1, N2, N3, sample size group 1, sample size group 2, and sample size group 3. For N1 is equal to 3, N2 is equal to 4, and N3 also equal to 4, which give the total sample size is 11, where 3 plus 4 plus 4. Next, we need to obtain the total value for each group, T1, T2, and T3. For T1 is equal to 17. 4 plus 6 plus 7 is 17. And for T2 equal to 43, where 15 plus 10 plus 8 and plus 10. And the last one, T3, is equal to 39. which is 12 plus 10 plus 9 and plus 8. The overall total, which is 17 plus 43 plus 39, is equal to 99. So when we have all this value, we can proceed to other calculation. For example, our main now is we want to obtain the SSA. So SSA can be calculated as T1 square over N1 plus T2 square over N2 plus T3 square over N3. So this one, 17 square over 3 plus 43 square over 4 and 39 square over 4. Why we stop until 3? Because we have only 3 groups here. Counter 1, counter 2, and counter 3. And then this value, you need to minus with the summation of S, which is 99 square over 11. And then the SSA, sum of square between groups, is equal to 47.8333. The next one is calculating the sum square of total, SST. For SST, summation of x square, whereby here indicates that the each value need to be squared. For example, 4 square plus 6 square plus 7 square plus 15 square plus 10 square plus 8 square up to until 8 square. So each of these value for counter 1, 2, and 3, you need to square and then you sum. So it gives you 979 minus with 891, which gives the total about 88. Next, when we have all of this value, now we can transfer all this value into the ANOVA table. So this is A and B. This one is SSA, whereby we just calculated. It gives the answer 47.8333, and our SST is equal to 88. So how to get SSB? SST minus with SSA, where the answer is 40.1667. For degree of freedom, number 1 can be calculated as K minus 1. Since our K is equal to 3, then 3 minus 1 is equal to 2. So we find the F2. The F2 is N minus K. The total sample size is 11 minus with 3, which gives you 8. And the last one total, 2 plus 8 is 10. And then we find MSA, mean square group, whereby the SSA divided by its own degree of freedom. So for this one, it gives answer 23.9167 for MSA, and for MSB, it is equal to 5.0208. Finally, we can obtain our test statistic, which is F. F is MSA over MSB, whereby 23.9167 divided by 5.0208. It gives you the answer 4.7635. Now, our ANOVA table is complete, but then we need to answer whether is there any significant difference in the mean waiting time of customers served by the 3 counters. Hence, to do this, we need to carry out the hypothesis testing procedure. So first, you need to state the hypothesis. The null hypothesis is mu1 equal to mu2 equal to mu3 because we have three counters, counter 1, counter 2, and counter 3. The alternative hypothesis is at least two means differ. Second step is test statistic. Just now, we already calculate our F, which is F equal to 4.7635. And then number 3, critical value. Let's assume our alpha is 0.05. Degree freedom number 1 is 2 and degree freedom number 2 is 8. This one you can refer to the previous ANOVA table, the F1 and the F2, 2 and 8 respectively. Then, by using this value, you can refer to table number 9. So according to table 9, 2 and 8 is 4.46. And then we proceed to decision. The rule is if the test statistic is greater than critical value, then we can reject the null hypothesis. Therefore, since our TS is 4.7635 is greater than 4.46, we can reject the null hypothesis. Therefore, the conclusion is there is a significant difference in the mean waiting time of customers served by the three different counters.